Hello and welcome to another video. In this video we're going to be working on get equals substrings within budget. And so in this one you're given two strings of the same length and an integer max cost. And max cost is the most cost you can use, and you can't use any more above that. And you want to change s to t, you want to change as many characters from s to t as you can. And changing the ith character of s to t costs this much, the absolute difference between the ASCII values. You want to return the maximum length of a substring of s that can be changed to be the same as the corresponding substring of t. If there is nothing, just return 0. So in this example, you can turn ABC into BCD because that costs 3. In this example, every character costs 2, so you can only change one character, so the max is 1. And then here, let's see, so A is already the same, and you can't change anything else. So it would just be A to A is what you have. So essentially, if we have a string like ABCD to BCDF, it's pretty straightforward to figure out the cost of a character change, right? You basically just take the ASCII value of one character minus the ASCII value of the other. So you don't need to know them exact, you just need to know the differences. And so whatever language you use, you can just do that. So B minus A in ASCII value would give you 1, because B would have some value, A would have some value, that's B minus 1, and so on. So essentially, we can represent these two strings as an array of like the cost to change the letter. So for every letter, we can just figure out like what's the cost. So for B, C, D, it'd be 1, for C to D, it'd be 1, and so on. And the basic thing here is just how far the characters are apart in terms of ASCII value. Because A has some ASCII value like, let's say, 70. If A had 70, then B would have 71, C would have 72, and so on and so on. So basically, changing a character to another character is just the like difference between them, like how far it takes to go from one to the other. So we can just have an array of the cost of changing one character to another. So let's say we have a cost of 3 here, cost of 5, 1, 2, 7, 3, 2, 1, 9, 8 or something. And let's call our max cost 15. So basically it's just asking you like, okay, what's the longest substring I can make with these characters that the total cost is 15. So for example, this wouldn't work, you know, and like something like this wouldn't work. So this is basically the problem. Like I have not even a string, I have an array of numbers. What's the biggest like subsequence I can get that's contiguous that adds up to 15 or less? What's the longest? And so this is like a really, really straightforward sliding window. So basically what you would do here is you would just keep growing your window until you're more than 15, and you would store the result. So like this would be valid, this would be valid, this would still be valid, so this is like 11. So this is all valid, so this is length 4, so we'd store length 4. Then when we try to put in this guy, now we have 18, right? So 8, 10, 18. And so we'd have to shrink it from the left. So we'd shrink from the left, so this would be like 9, 10, be like this. Yeah, so now this is valid. This is also length 4. Now we grow it again, and then when we grow, we have to shrink from the left. So it would be like this, 13, then we'd grow it again, and this is valid, right? So this is 15 right here. This is length 5, so now we update our best result to length 5. Then we grow it again, so 16, too long, so we'll shrink from the left until it fits again. So this is 15. And this is fine. Now we grow it again. So this is invalid. And so we have to get rid of 9. So we're going to get rid of these two guys. This is valid. Right? 3, 2, 1, 9 is valid. It's 15. And then when we put in the 8, we're going to have to get rid of pretty much everything else. So we'll have to get rid of this guy, this guy, this guy, like this. So the longest substring we were able to find was length 5. I think there were 2 of them. And that's our answer. So basically, I think... let's see, this was one of them. Or actually, not that one. At least I don't think it was that one, right? Like, I think this was one of them for sure. Yeah, so this was one of them, and this was one of them. Both of these are length 5, and both of these would be the answer. That's basically it. So you just calculate for every single letter what's the cost of transforming one letter to the other, and you just store the longest possible contiguous subsequence you have, like the longest window you ever made, and that's your answer. So pretty easy sliding window problem. So definitely one of the easier mediums. So let's code this. And we don't actually need to make an array here. We can just calculate this on the fly to use constant space. So we're going to have a couple variables. We'll have a result. We'll have a current cost. we'll have our left side of the window, and then we'll have our right side of the window, and that's all we need, I think. So we can have this. And I'll just make this shorter to make it easier. So left, right, there we go. Okay. So essentially for every character, we're gonna add it to our window. So per cost, we'll add the difference of the two ASCII values. And I talked about this before, but so converting a character to a number in Java, you actually have to do something like the character minus a. So for example, if you had like a z, you would do this. And then you would convert that to a number. Actually, that would be more for like character differences. But essentially what we want here is we want a number. So we want a number, and the number we want is the ASCII value difference. So the ASCII value difference is just going to be, so the ASCII value difference is going to be t caret I, or r in this case, minus s character at r. So one character minus the other character will give us the ASCII value difference. Then we convert that to a number because we don't want a character, we want a number. So we'll get that. And so we'll add that. And while our current cost is too big, we need to shrink our window. So we can say while current cost is greater than max cost, let's shrink our window. So this will be very similar, except now we're going to subtract the left character. So this will be left, and this will be left, and we can increment left here. So now at the end of the while loop, our window will be the right size, and you might have a case where, like let's say this character is cost like 30 or something, right? So let's say this character is cost 30, and what would happen is your right pointer would be here, and after the end of this, the left pointer would be here, which would be fine, because then when you do the right minus left plus 1, we're going to get a length of 0, right? We'll get 4 minus 5 plus 1. So it's totally fine in this case if the left is past the right, like that's fine. So we don't need to handle anything extra here. So we just maximize our result here. And like I said, if the left is past the right, we'll have a window of 0. If the left is on the right, we'll have a window of 1, and everything else will be longer, so it's fine. So we can say result equals the maximum of our old result and right minus left plus 1, standard length of a sliding window. And we just need to return the result. And that should be it. So I'd say this is like a easy medium problem. Screwed something up apparently, so let's double check what we did. Let's actually double check what we have here. So max cost 0, output 0, expected 1. Okay, so this should definitely work. Like this A and A should be cost 0. So let's see what we screwed up. So that's fine. Let's see. While current cost, so for the first letter, we should immediately get a cost of 0. So we can actually print it, I guess. So we can actually just do a print per cost, and we can also print the letter we're on. So maybe like this guy. Okay. Oh, this shouldn't be max cost. This should be t length. Okay, there we go. All right. I don't know how I got max cost there, but there you go. Okay, cool. So yeah, pretty straightforward sliding window. Definitely a problem you should be able to do if you've done a decent amount of LeetCodes, or not even like, this is like pretty basic. So let's talk about time and space and all that. And so this is a template I use for the sliding window a lot. I'll briefly talk about it just really quickly before we end here. So you make a result, you make like your current variable, you make your left, and then you have a loop that uses the right variable. You do something, and then while, basically this is like while window invalid, do something, and then store result. So that's kind of template you can use for almost all sliding window problems. Works really well. You just change what you write here, change what you write here, you know, some small changes. This basically always stays the same. This changes, and yeah. So this is, and typically sliding window is O(n) for at least the simple sliding window problems, is O(n) because you're just looping through your thing once. And so you're like growing it once and then shrinking it once, which is O(n). And typically space for a sliding window is O(1) because you just have a few variables. Yeah, so that's going to be all for this problem. If you have any questions, as always, write in the comments. And if you did like this video, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.